Hello everyone. Um, in this video we're going to cover concentrations. Last video we talked about solute is the small amount that's added to water. This one we review solvent is actually the substance that dissolves a solute. So water, for example, to form solution. So when solute dissolves in solvent, they form a solution. So we're going to talk about calculate molarity, percent by mass, percent by volume. Let's get started because we have a lot today. Concentration of a solution measures how much of the solute is dissolved in a specific amount of solvent. So concentration can be concentrated, like maybe strong coffee, strong tea, or very weak coffee, weak tea, dilute. The strength corresponds to its concentration. See, one is stronger than the other. One is more concentrated than the other. And of course, if I want it less concentrated, I just add more water. So make it less concentrated. And this is most of the stuff that we're going to do today. We're not going to do molality or mole fraction, but we're going to do the first three. So let's get started. Percent by mass is the ratio of solute, the mass of solute to the mass of the solutions, which is solute and the solvent added together. So percent mass is the solute over the solution, and the solution we said is the solute plus the solvent. So let's practice. Yeah, the mass of solute plus the solvent. Let's give you an example. In order to maintain sodium chloride concentration similar to ocean water, an equilibrium must contain 3.6 grams of sodium chloride per 100 grams of water. What is the percent mass of sodium chloride? So first, what do we know? The mass of solute, mass of solvent, and we want the percent. First thing we want to do is add the mass of the solute plus the mass of water. And then write down the formula. So we take 3.6 and we divide it by the total times 100. Okay? So 3.6 times 100 divided by 103.6. That gives us 3.5%. Okay? Another example, what is the percent by mass of sodium hydrogen carbonate in a solution containing 20 grams of the solute dissolved in 600 milliliter of water? Now, the first thing we want to put down what we have. The solute is 20. The solvent is 600 milliliters. What's the percent? Now, of course, in order for us to find the percent, we have to convert 600 milliliters to grams. And that, the density of water becomes very useful. Density of water is 1 gram per milliliter. So we take 600, multiply by 1 gram per 1 milliliters. Milliliters cancel out and we end up with 600 grams. So always automatically, if it's water, you know, if it's milliliters, then just change it to grams. But it's nice to know the step and show it if you're asked to show work. Then we find the total mass of the solution, which is 20 plus 600 grams. And then we write the percent equals the mass of solute over mass of solutions times 100. So 20 over 800 times 100, which is 20 times 100 divided by 800 is 2.5%. Not so bad. I think just the only one thing you have to remember is when you're given milliliters of water, you just have to remember the density is 1 grams per 1 milliliters. You just have to convert it and then add them up. Take the small amount divided by the total. Not so bad. Next formula that we want to talk about is percent by volume. Now, percent by volume, some of the examples are your diesel is 80% diesel, so 20% by volume. Also, isopropyl alcohol is 70% also by volume. So actually, over the emergency, when we ran out of hand sanitizers, they were saying take a 99% alcohol and add water to it. I think 2 parts to 1. A little bit of water, and then that will change the concentration or the percent to 70%. I can upload that video if you like. Because we were running out and we're going to create this at home. So we take a 99% and somehow add a little bit of water and make it a 70%. Let's do some examples. What is a percent by volume of ethanol in the solutions contains 35 milliliters of ethanol dissolves in 115 milliliters of water. So we list what we have. 35 and is the ethanol or solute, and 115 is the solvent, which is the water. And then first we find the total. The total is the solute, which is a small amount, divided by the total times 100. So we take 35 divided by the total, which is 150 times 100. Gives you 23.3%. Let's see. That was only, I think, example for volume. Let's do molarity. The one we want to concentrate on is molarity. Molarity is the number of moles of solute dissolved per liter of solution. So these are the units. Every time you see a capital M, right away you can replace it with moles per solute liter solution. So when we make a solution in the lab, we add the solids, dissolve it, and then if we're making 250 milliliters or 1 liter, then you stir and then add water up to the mark just to make it exact. Here's an example. 100.5 milliliter intravenous IV solution contains 5.1 grams of glucose. What is the molarity of this solution? The molar mass of glucose is 180.16 grams per mole. All right, let's get started. What do we have? We have the mass of solute, the molar mass, we have the volume, and we're looking for the concentration, which is M is moles per liter. So the first thing we want to do is change milliliters to liters. For every 1 liter, there's 1,000 milliliters. That's the first thing we want to do. Second thing, we want to convert grams to moles. So you take the grams divided by the molar mass, will give you mole. And then molarity is moles per liter, so you take the moles divided by liters. Okay? 0.083 divided by 0.1 is 0.282. Not so bad. Okay? First step, you convert milliliters to liters. Second, you convert grams to moles and then divide the moles per liters. Not so bad. All right, second example. How many grams of calcium chloride would be dissolved in 1 liter of 0.1 molar calcium chloride? We have the molarity, we have the volume, we need grams. So the first step is to convert to moles, find the number of moles, and then multiply by the molar mass of calcium chloride. So molarity is 0.1, so just plug in. The volume is 1. Moles of calcium chloride is 0.1. Just cross multiply. 0.1 times 1. So we have 0.1 moles of calcium chloride. Now the molar mass of calcium chloride is 111. Now, of course, you know, you look the mass of calcium and mass of chlorine, add them up, and you just multiply. So the mass that they're asking for is 11.1 grams of calcium chloride. Okay, I think that's it. So first, plug in. If they're missing moles, then we solve for moles. We cross multiply, and then multiply by the molar mass. Oh, there's one more formula that we, like, let's say you have a concentrated solutions, and you want to make less concentrated solutions, because sometimes we don't use the concentrated ones when we're doing the lab. So we take the concentrated one and then make it whatever required concentration. So this beaker shows concentration of the solution. Notice that the number of solute compared to the solvent. Solute are almost equal to the solvent. Very, very probably proportional to the water it's dissolved in. Now, this one is more diluted. It's added solvent. We added more water to the concentrated solution, so the solute is less proportional, or a lot less than the solvent in red. So the solvent is now more than the solute. All right. So there's a relationship. There's a formula: dilution equation. Molarity, M1 times V1 equals M2 times V2. So these are initially it's too concentrated, and the second one is when we add more water and make it less concentrated. So let's give an example. What is the volume in milliliters of 2 molar calcium chloride stock solutions when you use to make 0.5 liters of 0.3 molar calcium chloride? So plug in the values. So M1 would be 2. V1 would be, we don't know. M2, we want to make 0.3 from 2. And we want the final volume to be 0.5. What do we have to start with? Okay, so just plug in. M1, V1, so we want to solve for V1, so we divide this side by M1 and this side by M1. So V1 is V2 M2 over M1. So 0.5 times 0.3 divided by 2 equals to 0.075 liters. Okay, plug in, solve for whatever they're asking for. But that's not what they asked for. They asked for milliliters, and we have liters. And we know 1 liter has 1,000 milliliters. So we multiply by 1,000. And that would be your answer. Let's see if we have another example. Oh, 1 liter has 1,000 milliliters. All right. So we're done for this one, for this section. Review before you do your handouts, and I'll see you next video. Good luck.